Good morning, good afternoon, and good night. Doing a little classification of matter screencast for you here. Now, lots of times I've seen on tests that say, hey, what are the ways that chemists will classify matter, and people will go into solid and liquid and gas. And while that is one way to look at classifying matter, those are considered more phases or states of matter. And so when we're trying to break matter down into different categories, in terms of the actual particles themselves and the types of particles and how they're mixed, we use a different method and a different set of terms when we are classifying matter. So here we go. Starting off, matter is going to be classified as anything that has mass and takes up space. And so the definition of chemistry we're going to use in this class, the study of matter, the changes it undergoes, and the energy involved with those changes. And so we're starting out by knowing what matter is, how to classify it, what it looks like, so that we can identify when those changes have occurred, and then also be able to make some measurements about those changes with energies and things like that. All right. Two main divisions or categories of matter. You have pure substances made of one type of particle. So if I could take a particle model of this and I could look at it, every single pure substance, every single particle in a pure substance is going to look the same. Now we're going to differentiate between a couple different types of pure substances here in a minute, but when I look at them on the microscopic level, they're going to look the same throughout. Now, the other thing about pure substances is on a macroscopic level, they're also going to look the same throughout. It's going to look like one pure substance. It's not going to look like a couple different things. Mixtures. Mixtures are made of two or more types of particles whose ratios can vary from one sample to the next. And so what we mean by that is this. If I were to look at the particle model for a mixture, I'm going to identify two or more different types of particles. They're not going to be chemically bonded to one another. They're going to be physically mixed. Hence the term mixtures. And what's even more important is that I can have their ratios, like the number of one particle to the next, be different from one sample to another. And that can't be the case with pure substances. So mixtures, their composition can vary. Okay, so pure substances can be divided into two subcategories, elements and compounds. So an element is made of one kind of atom. Got a particle model for you here with the little purple circles. Those would represent the atoms. These would be things like hydrogen, carbon, oxygen. Any of those things that you're going to find on the periodic table are going to be represented by elements. Compound is made up of one type of molecule. Now, compound oftentimes will get confused with a mixture because we're talking about two or more different substances. Here's the difference. Here are examples of water molecules. Difference in a compound and a mixture is that, one, the two different types of particles in a compound are chemically combined. There are chemical bonds that are holding the oxygens and the hydrogens together. Also, the ratio of hydrogen to oxygen in a compound never changes. If I'm talking about air and I have a mixture of hydrogen and oxygen, I could go from one room to the next and have that mixture, the composition of that mixture, the ratios of one to another be different from one another. But when I combine those chemically to form water, it's always 2 parts hydrogen, 1 part oxygen. So the difference between compound and mixture has to do with the fact that in a compound, the ratios never vary and they're chemically bonded. In a mixture, they're not chemically bonded, they're physically mixed, and the ratios can vary. Now, there are two types of mixtures, homogeneous mixtures and heterogeneous mixtures. Now, homogeneous mixtures, particles are mixed evenly throughout, and this will give this mixture an appearance like it's a pure substance. It will look like it is one pure thing. So, for example, if I had salt water, for example, I can't see the different particles that are making up that mixture because the particles have been dissolved into such a small, atomic ionic level that I can't see them. And also, those salt particles get evenly distributed throughout the water. I don't have one area where there's a high concentration and one area where there's a low concentration. So down here, you can see this image is going to represent what a particle model for a homogeneous mixture might look like. You can see that the purple circles and the green circles are not chemically bonded. They are just physically mixed together, but they are evenly distributed throughout the sample of that substance. Now, heterogeneous mixtures, on the microscopic level, the particles are not evenly mixed. So you can see here in my heterogeneous mixture example, the purple circles are kind of grouped together, and then the green circles are kind of grouped together. Now, to the naked eye now, because of this, I can identify the two different things that have been mixed. Or even if I can't identify what they are, I can at least identify that there are two different substances there. So homogeneous mixtures look like one pure substance, but it's because their particles at a very small level have been evenly distributed. Heterogeneous, again, uneven distribution of the particles at the microscopic level, and then actually you can see the different parts then because of that. So I get a green area and a purple area because of that. I think it might not be a bad idea somewhere in your notes to go ahead and get some kind of flow chart running. Maybe just something as simple as this. This is a pretty good one, showing elements, compounds, homogeneous mixtures, and heterogeneous mixtures on the particle level. So eventually, our objective will be to make sure that we understand what they look like particle level, definitions, and then examples of each, and then be able to explain why they fit that category. So know that that is eventually what we need to do with this, and that's the practice that we will be getting in class when we come back after working with this. Thanks.